Hi, Dave here to finish up Chapter 7. In the second video of a two-part series, I want to talk about Section 7.2 and 7.3 focused on inheritance. And from a very high-level perspective, inheritance is very important. We need inheritance for GUI programming, as we will be inheriting from Java GUI classes. Inheritance is going to be important when we want to create our own exception classes, and we need inheritance for polymorphism that we'll be talking about next week. Now, it's going to take you a long time to really feel comfortable with inheritance. We understand that. The important thing today is to understand the mechanics and what inheritance can do. Today I'm going to focus on types, that you can always create an instance and put it into a variable or parameter of any type that is an ancestor of your class. I'm going to talk about the keywords final, this, talk about protected and package access, the class called object, and the get class method and the instance of keyword. A concept to come out today is that every class in our system, whether it extends a base class or not, has object in its hierarchy. Now, we talked last class that any class, before it can be constructed, it must create an instance of its base class. So if I wanted to create a full-time employee, before I can create a full-time hourly employee, I have to create an hourly employee. And before I can create an hourly employee, it needs to create an employee. So as long as we're creating an instance and putting in a variable of a type that's higher than it in its hierarchy, the compiler is going to be happy. So I can put a new employee into an employee variable. I can put a new hourly employee into an hourly employee instance variable. Same with salaried employee, part-time employee. But here I'm going to create a new hourly employee and put it into a variable emp1 of type employee. That is safe because I'm putting it into an instance variable of someone higher than it in its ancestry. I can do the same thing for salaried employee. I can put into an instance variable emp2 of type employee. Employee is higher than salaried employee. It's an ancestor of salaried employee. However, I can't go down. I can't go the other way. I can't take an instance of an employee and put it into a variable of one of its descendants or children. So I can't do the first one. I can't take a part-time employee and put it into a salaried employee. They're not in the same inheritance hierarchy. Once again, I can't take an employee and put it into a variable of type part-time employee. I can't go down, I can only go up. Now, objects are smart in that they always remember what they were created with when you call their constructor with new. However, depending on the variable type that the objects are put in, the compiler will only let you call on them methods that the type that they are in knows about. For example, if I create a new hourly employee and put it into a variable h1 of type hourly employee, I can call the get wage rate, the get hours methods, the get name, or the get hire date methods. Those are the four methods that an hourly employee knows about. But if I create an hourly employee and put it into a variable E1 of type employee, even though I was created as an hourly employee, when I get put into an instance variable of type employee, I can only call methods on that instance variable that employee knows about. So here I can only call E1.getName or E1.getHiredDate. So an object of a derived class has more than one type. It has the type of the derived class but it also has the type of the base class. So an hourly employee is an instance of hourly employee, and it's also an instance of its base class employee. More generally, an object of a derived class has the type of every one of its ancestor classes. There's a final modifier. We can prevent a method from being overridden in a descendant class, in a subclass, just by putting the word final in front of it. In a similar way, we can prevent a class from being subclassed by putting the word final in front of it. The this constructor. Within the definition of a constructor for a class, this can be used to invoke another constructor in the same class. We would not call a constructor in the same class by its actual name. We actually use the word this. Now, if it's necessary to include a call to both super and this, the call using this must be made first. And then the constructor that is called must call super as its first action. The next slide I have an example. Here I have a constructor class name that takes no arguments. It wants to call the two argument constructor within the same class. So it calls its two argument constructor by saying this, and then it gives the two arguments. I call this, I didn't call a class name, I have to use the word this, and I give its two arguments. It will call the constructor with two arguments, and note that this one now has super as its first executionable line. We've had public, we've had private access. There are two other access types, protected and package. If a method or instance variable is modified by the access type protected, then it can be accessed within its own class definition, inside any class derived from it, using the word extends, and it can be used in the definition of any class in the same package. So it's a little bit better than public, but it still offers very weak protection. If you don't put an access modifier in front of a variable or method definition, it will have package access. This is also known as default or friendly access. Instance variables or methods having package access can be accessed by name inside the definition of any class in the same package. This offers a nice capability for people that develop their own package, which is a library, and the different parts of the library want to communicate with each other. The example in the book had a package with 3 classes in it, shown inside this little blue boundary, and 2 classes outside the package. Now within the package, we had class A that had 4 instance variables, one of type public, one of type protected, one of type package, default or friendly access, and one of private. Class C extended A, and since it's in the same package, it can see the instance variables v1, v2, v3, but not v4. Class B is in the same package. Because it's in the same package, you can also see v1, which is public, v2, which was protected because it's in the same package. You can see v3, but it can't see the private data member. If we go outside the package, Class D is going to extend Class A. So it will be able to see public and protected instance variables. It can see v1, v2, but it cannot see v3 or v4. Class E, outside the package and not inheriting from A, will only be able to see the public instance variable v1. There is a class called object. In Java, every class is a descendant of the class object. Every class has object as its ancestor. Every object of every class is of type object, as well as being of its own class. If a class is defined that is not explicitly a derived class of another class, and it doesn't use extends object, it is still automatically a derived class of the class object. So we never extend an employee to be a descendant of object. It automatically has it. So here I'm showing a part-time employee instance being put into a variable O1 of type object. Completely legal because object is the ancestor of part-time employee. Same with hourly employee. It's legal for me to put an instance into the variable O2 of type object. The class object is in the package Java lang, so it's automatically imported. It allows some flexibility for methods to be written with the parameter of type object. That way, the parameter can be replaced by an object of any class. Very powerful. And some library methods take advantage of this. Now, the class object has some methods that every class inherits, such as equals in toString. And every object inherits these methods from some ancestor class. It could be the class object itself, or it could be a class that inherited these methods and already overrode those. Either way, these inherited methods should still be overridden with definitions more appropriate to the given class. Here I'm showing the Java doc for the class object, and you can see some of its methods. Two of the methods that we're talking about always overriding is the equals method and the toString method. Now the right way to override equals is by declaring public Boolean equals and taking a parameter of type object. Note I'm putting the annotation override in front of it. Some of the previous definitions we saw in the book that did not take a parameter of type object was overloading and not overriding the equals method. Now the overridden version of equals must meet the following conditions. The parameter must be of type object. And they're going to have to typecast that to be of the class employee. But before typecasting it, we need to make sure that the other object is not equal to null. Then we try to typecast it only if it actually is an instance of employee. So here's a nice way to do it. Here's the overridden method taking a parameter of type object. First we're going to check against null. If it's null, we're going to return false. We're next going to check its class to make sure that other object is of type employee. So is the other object's class the same as the one we're in? If not, return false. Otherwise, it's safe to do the cast and then to compare the variables. So get class. Every object inherits the same get class method. The invocation of get class on an object returns a representation only of the class that was used with the new operator to create the object. And the result of any two such invocations can be compared with double equals or not equals. There's one other method in Java, or keyword in Java, called instance of. Then the instance of operator checks if an object is of the type given as its second argument. So here we're checking an instance of employee, or instance variable EMP, to see if it's an instance of hourly employee. And this will return true if it is an instance of hourly employee, but it will also return true if it's an instance of any other descendant types of hourly employee. So a lot of times you'll see people use instance of a get class, but get class is typically preferred because it's more exact. Okay, that concludes this lecture. Have a nice day.